Hello students, welcome to IK Education. Today we are going to learn how to write electronic configuration. Before learning this, we have to revise what is atom, subshells, shells and orbital. In the last video you remember I tell you that atom contain a centrally located nucleus which is a positive charge because of protons and around the nucleus electrons revolve in a orbit known as shell. Electron is a negatively charged particle. Then there are KLMN shells. Shells contain subshells. Shells contain subshell. Every subshell has a specific number of subshell. Shell KLMNOP shells, and this is known as energy level 1, energy level 2, energy level 3, energy level 4. N is principal quantum number 1. N is principal quantum number 2, 3, 4, energy level 5, 6, 7. Then every shell contain specific number of subshell. K shell contain only one subshell. L shell contain only two subshell, S and P. And M contain S, P, D. N contain S, P, D, F. 5 contain S, P, D, F. And P contain S, P, D and Q contain S, P. These are subshells. This is shell. Shell containing subshell. Energy level 1 K shell contain only S subshell, means S subshell has only one orbital. S subshell has only one orbital. P subshell has 3 orbital. D subshell has 5 orbital. F subshell has 7 orbitals. We can calculate the number of electron in each energy level or shell. K shell can occupy only 2 electrons because S subshell has only one orbital, and energy level 2 L shell has only 2 subshells. It means it has only 8 electron. It can carry 8 electrons because S has only one orbital and P has 3 orbital, and 2 electron occupy in one orbitals. 1 orbital can occupy 2 electrons. By calculating this, you can see 2 plus 6. We have 8 electron. M shell has 18 electron. N shell has 32 electrons. O shell has 18 electron, 32 electrons, 18 electrons and 8 electrons. You can calculate. Let's take an example. Before starting electronic configuration, you have to know that it is based on two rules. First, Abbas principle, and second, first Abbas principle and second Hund's rule. Abbas principle and Hunt's rule. Abbas principle tells us that electron occupy occupies in orbitals. Second, first electron occupy lower energy orbital. And third point is fill the electrons in increasing order of energy. Means you have to fill the electrons in these subshells orbitals. This is subshell. When we write S with a number, S with the 4 number, it is orbital, and without number it is subshell. Without number it is subshell. So write down this. You can write this as based on energy of orbital. Energy, fill the electron in the increasing order of energies, energy of orbital. Orbitals. We can understand this Abbas principle by taking a one example. See, every subshell has orbitals. This is subshell. When we write a number with subshell, for example, if you write 6, this is orbital. Yes, orbital. Like that, based on energy of orbital, which orbital has more energy and which orbital has lower energy, we have to understand here. First, 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f. This is our first subshell. This is our first subshell and first shell. This is our first subshell and second subshell. Subshell first and second, and these both come in shell. These both come in shell. First energy level occupy 2 electron. Second energy level occupy 2s, 2p, 8 electron. Third shell occupy 18 electrons. D has D has 5 orbitals in which 10 electrons can fit. By taking one example, which subshell has more energy and how first electron occupies lower energy orbitals, which orbital has lower energy and which orbital has higher energy. Let's understand by a simple rule, n plus n rule. N plus L rule. Here n is principal quantum number, and here L is azimuthal quantum number. Azimuthal quantum number. First question is, which orbital has lower energy? 2p and 2s. 2s and 2p. By this rule, we can find which orbital has lower energy and which orbital has higher energy. See, n is a principal quantum number, means 1, 2, 3, 4. N is equal to 1, 2, 3, 4. N is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. And azimuthal quantum number means L. L. S has 0, P has 1. Here is our azimuthal quantum number. S subshell has 0 azimuthal number. P has 1, D has 2, and F has 3. By this data, you can calculate which orbital has more energy and lower energy. N plus N rule. Here 2s. Here we take 2s. Here 2 is our principal quantum number, and here S is our azimuthal quantum number. By 2 plus, here 2 plus, yes, azimuthal quantum number is for S is 0. Then our answer will come 2. Then after 2p, azimuthal quantum number 2 and principal quantum number 2 and azimuthal quantum number for p is 1, and our answer is 3. So the energy of 2p is greater than 2s. We can write whole by this method: 1s, 2s, 2p, 3s, 3p, 3d, 3f. Write this in an increasing order of energy. First, we have to take all, we have to calculate all of us n plus L rule. N plus L rule. S is principal quantum number. Principal quantum number is 1. S has azimuthal quantum number 0. 1 plus 0. 2s has 2 principal quantum number, yes, 0. 2 plus p. P has 1 azimuthal quantum number. Here our answer is 1. Here our answer is 2. Here our answer is 3. And here our answer is 3 plus 0. Here our answer is 3. Here our answer is 3 plus p 1. P has azimuthal quantum number 1. Here our answer is 4. 3d. 3 plus d. You have to learn that L equals to 0, 1, 2, 3, 4, and here S, P, D, F. So D has two principal quantum number. D has 2, and our answer is 5, and 3 has, our answer is 6. This is the increasing order of energy by which we can write the electronic configuration. Here is a tie within 3 and 3. When we use n plus L rule, when we got tie, we have to take a dominant as n, not l. Dominant as principal quantum number, whose principal quantum number is greater, 3 and 2. 3 is greater than 2, then 3 has more energy than 2p. 3s has more energy than 2p. In we have to arrange this in an increasing order of energy. First is 1s. 1s is greater than 1 is 1s. Second is 2s. Third is 2p. Third is 2p. 1s, 2s, 2p, 3s, 3p, 3d. 1s, 1, 2s, 2, 2p has lower energy than 3s. 2p, 3s, 3s has more energy than 2p, 3p, 3d, and 3s. By the above principle, we have to first fill the electron in 1s, then 2s, then 3s. And Hund's rule, you have to write this. Here Hund's rule is electrons in a subshell are paired. Electrons in a subshell are paired only when all the orbitals are half filled. Half filled. Electrons in a subshell are paired only when all the orbitals are half filled with a parallel spin. Let's understand with this an example. When a p orbital, when p subshell has three orbitals, p subshell has three orbitals, and p has half filled. Here now is p is half filled. Electrons in a subshell are paired. Electrons will get paired only. Electrons will get paired in a subshell only when all the orbitals, all the 1, 2, 3 orbitals, p has 3 orbitals, all the orbitals are half filled. Here all the orbitals are half filled with a parallel spin, with a parallel spin, or like this parallel spin, parallel spin, not like this. This is wrong method. When the electrons are half, when the orbitals are half filled with the parallel spin, they get paired. Understand? Let's solve 1 to 15 atomic number with electronic configuration. 1, 2, 3, 4, 5, 6, 7, 8. And here this is energy level or shell. 1s, 1s, this is our orbitals. 1s, 2, 2s, 2p, 3s, 3p, 3d, 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 4p, 4s, 4p, 4, D, 4F, 5S, 5P, 5D, and 5F, 6S, 6P, 6D, and 7S, 7P. You have to fill the electrons in this order. Firstly in 1s orbital, then 2s, then 2p, then 3s. Then from 3s you have to come back to 3p. 3p will fill in the 4s, and 4s will come back to 3d and 4p. 5s, and this will come back to 4d. This will 5p, 6s, and 4f, 5d, 6p, 7s. This is the energy level. This is lower energy level, this is higher energy level. And you can also calculate with the n plus n rule. For example, if we take 5s, 5s and 4p, 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 5s and 4p. N is a principal quantum number by n plus L rule. N plus L rule. 5 is principal quantum number. 5 plus S has 0 azimuthal number, and P has 4 plus 1. P has 1 azimuthal quantum number. Your answer is here 5, and here answer is our 5. When we got a tie, I told you that N is a dominating one. N is a dominating one over azimuthal quantum number. N is dominating over azimuthal quantum number. So 4p has lower energy and 5s has higher energy because of n, because of principal quantum number. So our first electron goes in 4p, then 5s. Let's take an example of hydrogen. Hydrogen's electronic configuration is, for hydrogen atomic number is 1. So first electron goes in s orbital, 1s. You can write it as 1s, yes, and only one electron which is half filled. Hydrogen, then helium, helium. Helium has 2 atomic number. Helium's atomic number is 2, therefore 1s 2, 1s1, here is 1s1, and here is 1s2, because s orbital contain 2 electrons. Here is our s orbital and containing 2 electrons. Then another example, hydrogen, helium, lithium. Lithium's atomic number is 3, and we have to fill electrons in this manner, lower energy to higher energy. First 1s 2, 2s 1, 1s2, 2s1, and you have know that s has one orbital and can carry 2 electrons. p has 2 p has 3 orbital and can carry 6 electrons, and d has 5 orbitals, can carry 10 electrons, and f has 7 orbital and can carry 14 electrons. 1s 2s, 1s 2, 2s 1. Here 1s is full and 2s is half filled, half filled. You can solve this first, second, third, fourth. Can you solve this? Please try to solve this. Hydrogen, helium, lithium, beryllium, boron. Beryllium has 4 atomic number, boron has 5 atomic number. Here you can write it as his its electronic configuration as 1s, 2s, 1s2, 2s2. And fulfilled, here is 1 s orbitals are fulfilled. Then 1s2, boron has 5 electrons. 2 electrons get in 1s2, and 2 electrons then enters to 2s2, then one remaining electron enters into 2p1. Here total 5 electrons are packed, and our electronic configuration for boron is 1s2, 2s2, 2p1. You have to solve this. Carbon's atomic number is 6. Then you have to fill 6 electron in this orbitals. 1s2, 2s2, 2p2. Here our 6 electron are get packed, and this is electronic configuration for carbon. Nitrogen has atomic number 7. 1s2, 2s2, 2p3. Here our 1s2, 2s2 is full filled and 2p3 is half filled. Then oxygen atomic number 8. First fill the electron in 1s. Yes, can occupy 2 electrons. Then 2s, 2p, 3s. This is the energy flow of electrons. Higher energy, lower energy. Electrons first occupy in lower energy orbitals. 1s2, 2s2, 2p4. Here 4 plus 4, 2 plus 2, 4 plus 4, 8 electrons. And oxygen atomic number is 8. And for fluorine, here is electronic configuration 1s2, 2s2, 2p5. Neon atomic number 10. Atomic number 10. You can write this. Neon's atomic number is 10. Then the electronic configuration will be 1s2, 2 electrons, 2s2, 2 electrons, 2p6, 10 electrons. 6 plus 2, 6 plus 2 plus 2, 10 electrons. 2p, 2p6. Then electronic configuration for nitrogen will be 1s2, 2s2, 2p6, 2p6, then 3s2, 3s2. Then for electronic configuration for magnesium will be 1s2, 2s2, 2p6, 2p6 and 3s2. An electronic configuration for aluminum you can solve. You try to solve it. Here the atomic number for aluminum is 13 and electronic configuration is 1s2, 2s2, 1s2, 2s2, 13 electrons. We have to fill 13 electrons. 1s2, 2 electrons, 2 electrons, 6 electron. Total 10 electrons get filled, 2p6. Remaining electrons are 3. 3s2, 3s2, then 3p1, 3p1. 2 plus 2 4, 4 plus 6 10, 10 plus 2 12, and 12 plus 1 13. Then for silicon 1s2, 2s2, 2p6, 3s2, 3p2. And for potassium 1s2, 2s2, 2p6, 3s2, and 3p3. This is phosphorus, not potassium. Phosphorus. So student, in this video we have completed our electronic configuration to atomic number 15. In the next video we will continue from 16 to number 13, atomic number 13. We will. Thank you students for watching video. If any doubt you can comment me, and in the next video we will discuss from number 16 to 30 electronic configuration. Thank you.